Hello, my name is Andrea Garcia, and I am an R&D scientist in the Genetic Sciences Division of Thermo Fisher Scientific. Today I will be presenting on the evaluation of dried blood specimens for HIV-1 drug resistance testing using a commercial HIV-1 drug resistance assay. This work was recently completed with the help of the New South Wales Reference Laboratory at St. Vincent's Hospital in Sydney, Australia. In this study, the primary objective was to test a commercial HIV-1 genotyping assay with dried blood spot specimens. While plasma has long been the gold standard, there are some caveats to handling, transporting, and storing plasma. Dried blood spots offer an alternative field-friendly solution, which allows for greater access to HIV-1 drug resistance testing. The Applied Biosystems TaqPath-Seq HIV-1 genotyping kit was selected for genotyping the protease, reverse transcriptase, and integrase regions of the HIV-1 pol gene. Performance of the TaqPath kit was evaluated using the WHO HIV ResNet Laboratory Network Validation Framework for HIV-1 drug resistance genotyping with dried blood spots. The study included 79 stored dried blood spot samples from ART-naive and ART-experienced individuals. Nucleic acid was extracted from 2 10-millimeter dried blood spots per sample using the Applied Biosystems MagMax viral pathogen nucleic acid isolation kit and genotyped using the TaqPath kit. All samples were also genotyped using the reference HIV-1 drug resistance test from the New South Wales State Reference Laboratory. HIV-1 drug resistance results were interpreted with the Stanford HIV database algorithm, and genotyping profiles were compared to reference test nucleotide sequences for accuracy. Sensitivity, precision, and reproducibility were also assessed across different subtypes. Figure 2 has a pie chart of the HIV-1 subtypes that were included in the study, including subtypes A, B, C, CRF01AE, and F, while Table 1 shows the assessment criteria that was being evaluated. Overall, amplification was achieved in 89.9% of samples for the protease and reverse transcriptase region and 84.4% for the integrase region. 100% of amplified products were genotyped successfully, and when broken down by viral load, the genotyping was successful in greater than 90% of samples with a viral load greater than 5,000 copies per mil. 50% of the samples that had a viral load between 2,000 to 5,000 copies per mil were successfully genotyped for protease and reverse transcriptase, while 30% were successfully genotyped for integrase. There was a statistically significant difference in genotyping success rates between the low and high viral load groups, but not between HIV-1 gene regions. When evaluating the kit accuracy, precision, and reproducibility, high nucleotide similarity and drug resistance mutation concordance was observed, exceeding 99% for all tests. There were 2 samples that experienced discordant mutations from the expected reference sequence. These are shown in Table 3. The TaqPath kit did identify additional mutations, and these are indicated in the bold red text. In conclusion, the TaqPath kit is meeting the WHO HIV ResNet criteria for accuracy, precision, and reproducibility when using dried blood spots. The amplification sensitivity is also meeting the criteria for samples with a viral load greater than 5,000 copies per mil. Integrase performance for samples with the viral load between 2,000 to 5,000 copies per mil fell below the 50% expected outcome. However, the low viral load group did have a limited sample size and did not represent all of the HIV-1 subtypes. In addition to those 2 study limitations, another difference is that the extraction method used between the 2 assays being compared did use a different extraction method. This could have potentially attributed to the identification of some discordant mutations. In the end, we would like to thank all of the study participants and the New South Wales Reference Laboratory staff for their assistance with sample collection and characterization. Thank you very much for your time today.